another way that works for finding an IP address is by asking Google what my IP address is, and there are various services, including just Google itself, that will tell me what it is. So it turns out to be that 70.19.54.83. And let's see if I can find that here. Um, again, I think the issue with things not matching up here has to do with NATs, something called so that's NAT, network address translation. So we'll come back to that another time. But the message that ultimately gets sent by IP in response to me typing in facebook.com is one that looks like this. There's these 20 bytes of data that containing my IP address and Facebook's IP address, and then these 20 bytes of metadata containing Facebook's port, or at least the first port that I'm going to try to connect to at Facebook, and a port chosen on my end, and then the HTTP message. What's not the Internet Protocol, given this message, its job is to send this message to the node with that IP address. So at this point, somehow the system had to figure out what IP address to plug in here. I just pasted it in there by calling ping, because ping because ping will look up the IP address of a URL. But how did it do this? So there's like this missing step here in this process that hasn't been explained. Somehow ping or tools more generally have to have a way of, given a URL, finding out what the IP address of the machine with that URL is, so that it can be plugged in here. And the thing that can do that is, or the protocol that provides that service is DNS. So when I, as the user, enter facebook.com, the system doesn't literally run ping, but there's a query that is transmitted in the DNS protocol to a DNS server that, through a somewhat complicated multiple-step process involving multiple different servers, if successful, returns this IP address, and after doing that invisible round trip that the user is not aware of, so the user enters facebook.com, the system invisibly sends a DNS request to a DNS server asking for a lookup of the IP address corresponding to facebook.com. A chain reaction process occurs as a result that hopefully results in a DNS response message being sent back to my system, telling it that facebook.com's IP address is that number. And then it's at that point that this this header can be filled in in this IP message, which now can be transmitted to facebook.com, asking it to send me back this web page. And as I say, most of the time that this is completely invisible to the user and works seamlessly, but it occasionally breaks down, and the design of the system that performs this service is highly non-trivial and complex. There's a couple of nice analogies. So the URL of a machine compared to its IP address is a little like your name written in English or in whatever language your name is a name in. Your name in natural language versus your social security number, or your ID number from issued by whichever government. Or another analogy is to the URL versus the IP is like an entry in your contacts on your phone versus the phone number that that contact has dialed when you tap on that. And as I was talking a bit about at the beginning, just to close up and to emphasize again the scale, part of the reason that the DNS service is so non-trivial is because of the size of the network and the number of URL IP address pairs involved, and the number of them, the frequency with which large numbers of them change, with servers coming online and going offline at a frequency at which it wouldn't be possible to instantly announce to all of the nodes on the network every time one node with an IP address and a URL comes online or goes offline. In the very early days of the internet, this might have been possible, but at least at some recent time, there were something like 350 million different domain names. Domain name meaning like facebook.com. Within a domain name, there will typically be many servers contained within it, not just one, let's say 10, I don't know. So there are very easily billions of servers with on the internet with URLs and IP addresses, some non-trivial fraction of which are being rebooted and taken online and offline all the time. So the scale just makes it prohibitive to try to update everybody instantly every time that happens, every time there's a change in the topology of the network, every time one of those nodes blinks into or out of existence. So therefore, the DNS system has to be designed in a to some degree in what's called a lazy processing way or lazy evaluation way, where you only make the requests to get the like to double to so you only ask for the changes kind of as you need them. So rather than updating everybody every time there's a change, instead, whenever somebody needs to find out what some URL's IP address is, or every once in a while, if they already know what a URL's IP address is, but it's been a while since the last time they've checked, they might decide it's time to double check to see if that URL is still associated with the same IP address, or has it changed to become something else. There's this complicated set of procedures to decide when to ask for these confirmations that things haven't changed and when not to. So there's caching that takes place at various levels within this system of DNS servers. So as much as possible, you would prefer to just remember locally what the IP address of a URL was, if you have good reason to think it's not going to change. But nothing, it eventually will change. You can't rely on it forever. And so how often should you actually do the double check? Alexa, stop. And so how often this double checking happens, meaning how long of caching is allowed or recommended, varies depending on the level of the DNS hierarchy that you're in, which we'll discuss. And it involves something called time to live values, TTL values. About which more in future videos. But so just one last, so just one last point. If translating between IP addresses and URLs causes all this trouble, which is so complicated and difficult and such a huge headache to perform and to maintain and build systems that will reliably keep things up to date. If it's all this trouble translating between IPs and URLs, why do it? Why not just use URLs and forget about IPs altogether? And the answer is that the internet is made out of IP. So the core protocol that the whole internet runs on is IP, which identifies network nodes by IP address. IP doesn't know anything about URLs. It doesn't know anything about Facebook.com. IP, the only naming tool, the only naming concept built into IP is IP addresses. You wouldn't be able to get rid of IP addresses without effectively replacing the internet with a different network. And moreover, not everything has a URL. Not every server has a URL. For one thing, when you plug in a web server and connect it to the internet, connecting to the internet, if what that effectively means is getting assigned an IP address by the internet. You can more or less think of those two things as being synonymous. Getting online, getting connected to the internet equals being assigned an IP address by the network. It doesn't automatically give you a domain name. Getting a domain name is a separate process that involves registering with an ISP and paying a fee to buy or lease the URL from the people who own it. It's an entire separate and optional process. Optional in the sense that you can set up a web server, connect it to the internet, have it go online, and have it run all day successfully without ever having a URL assigned to it. If you somehow communicate to your users the actual raw IP address of your web server, then they can enter that IP address in their browsers and connect to your web server and use it the same way they would use any other web server. So like, so like here's Facebook, this 157.240.220.35. So here I'm entering it into my address bar. And so it gets resolved as Facebook because my browser knows. So my browser can run the DNS queries as well. But like the point is that entering the IP address into the browser brought me to Facebook. And similarly, so here 192.168.1.1 is the IP address for my my FiOS router. Right? So we most often enter URLs into the address bar, but entering the actual IP address into the address bar also works. It just cuts out the need for that first step. The web browser didn't have to run a DNS query and look up the IP address for the URL because I gave it the IP address directly that I wanted to go to, and that works fine. By the way, if I enter the, so when I enter the IP address as the destination, then in the HTTP GET message, the IP address is what would be plugged in here as the in the host field. So not everything on the internet, not every server on the internet has an IP. Web servers can function perfectly well without ever being, did I say without an IP? Not every web server, so Control Z, I think, for the sentence I said two sentences ago, not every web server necessarily has assigned to it a URL. A web server can function perfectly well having users request it directly by its IP address rather than by a URL. It's just an issue of getting the users to know what that IP address is. And of course, in real life, you don't want your users to have to type in random looking numbers, which, is what an IP address would look like to them. But moreover, not only do web servers not necessarily have URLs, there can be lots of other servers that have nothing to do with web URLs. There are mail servers and DNS servers and BitTorrent servers, and there are all sorts of different kinds of servers that have, that don't have to have anything to do with the web or with URLs. They all have IP addresses, though, which is what makes them servers on the internet. The point here being that URLs are a very sort of specialized concept, relatively specific to the web, not completely. So many of these other servers do get URLs over time, over time, but there's sort of for kind of user friendliness purposes, but URLs are this extra optional additional layer of pretty printing, of syntactic sugar, of user friendliness, that intended for this one particular application and similar applications, intended for web access and similar kinds of end user activities that are not at all inherent in the internet itself. So short of replacing the internet with a different fundamental network, we're stuck with having the internet network infrastructure itself be based entirely on IP addresses on the one hand, and on the other hand, having users using websites expecting to be able to enter URLs without having to think about or worry about or even know about IP addresses. On the other hand, we're stuck with IP addresses and URLs and the need to translate between them. So in future videos, we'll see in some more technical detail how that process works.